Yeah, so very good evening to all of you. So welcome to the iitiansgateclasses classes. In this session, we are going to cover the shear force and bending moment diagram and how to draw perfectly, for any type of figure which is given in the gate examinations. So before understanding the shear force and bending moment diagram, we would like to see the what are all the types of support we have, uh, in our strength of material, so that because very first step for drawing the shear force and bending moment diagram is to calculate the reaction forces, right? So when you see these types of beams and the loads and reactions, we have very first type, we say that simply supported beam, SSB, right? What we say simply supported beam, right? In this simply supported beam, what you are observing, there will be two supports, hinge support as well as, roller support, where there will be some reaction forces will be offered, right? As you can see. And what all the types of loading will be there, that will be basically restricted by the reaction forces offered by the support. In this support, what you are observing, one is a pin support. This support I'm calling this to be, I'm calling what, pin support. And I'm calling this to be a roller support. This particular part, I'm calling this to be a roller support. There is a slight difference between roller support as well as pin support. Pin support will not allow any horizontal as well as vertical movement, but roller support will allow the translation in the horizontal directions, but it won't allow the translation in the vertical directions. That's why it is offering the reaction in the vertical directions. Second types of support, we are calling this to be cantilever support, cantilever beam. In this cantilever beam, there will be one fixed end, just like this particular beam is connected to some kind of wall, like this. Now you cannot allow any rotation also. In pin support, and the roller support, you are having some, basically you are allowing some kind of rotations. You take a pen and hold with your left hand. Can you able to rotate your pen? Yes. If you are able to rotate means there will not be any reaction movement. But in this type of cantilever support, there will be reaction movement also will be coming. Third type of support we are calling beam with the overhanging part. Again, simply supported beam only, but some portion of the beam will be extended, beyond the uh, support, right? So these are the supports which are very, very important for drawing the shear force and bending moment diagram, right? One more types of beam we have, the types of beam is nothing but continuous beam, where we have the more than two supports, right? Beam in which we have more than two supports, then we say that this particular beam is continuous beams, right? This continuous beam, as far as the statically indeterminate or statically determinate beam, this is nothing but statically indeterminate beams. Why I'm calling this to be statically indeterminate? Because here the number of unknowns, when you count the number of unknowns, 1, 2, 3, and 4. We have 4 unknowns, but we have only 3 equations. What are the 3 basic engineering mechanics equations? Static equilibrium equation, summation of forces in the x direction is equal to 0. Summation of forces in the y direction is equal to 0, and summation of movement about any point has to be 0, right? So these are the things we will cover in detail in the course, but as far as the this demo lecture point of view, I'm just telling you that in which category this particular beam is coming under, right? As far as this particular beams, these are all statically determinate beam. Statically determinate beams. Why I'm calling this to be statically determinate? Because with the help of static equations, we are able to determine the reactions, right? Now, let's figure out some of the important sign convention before drawing this shear force and bending moment diagram. Let's see sign conventions. Shear force. See, very first thing you would like to ask me, sir, what is what is the meaning of shear force? It is the algebraic sum of the forces which are acting on a beam from either side. That means when you consider a beam, let's suppose you are considering beam, it is being subjected to so many types of loading conditions. So many types of loading conditions. Let's suppose, for example, and I'm cutting over here, I'm just asking you, what is the shear force at this particular section? If I'll be asking you shear force, if I'll be asking you what is the shear force at this section XX, what you will say? Summation of forces. Which forces? Vertical forces from either side. Either you can consider right side, or you can consider summation of forces from the left side, right? That is the meaning of shear force. And why we are able to calculate, why we are calculating, because for the designing of direct shear stress, it is very important to know what is the shear force which are acting at a particular point. Similarly, what is the bending moment? Summation of all the moments from either side, right side or left side. That will be called as bending moment, right? Now, regarding sign conventions, it's very important. So here we have, suppose any section we have considered, and if the forces are acting like this, W is acting like this, then what I'm just writing, summation of forces in XX direction will be plus W. Either you are moving from this side or this side, right? Either you are moving from the right side or from the left side. We are calling summation of forces at a particular section will be plus W. Now, when we have these load conditions, something reverse manner, let's suppose, for example, if it is given in the reverse manner like this, you are moving from this side or from this side, so shear forces will be considered as negative, my dear friend. Or we are calling this to be minus W. It's better one to write minus W, right? So these are the sign convention for shear force, right? Now, what is the sign convention for bending moment? Again, this is a very easy one. Everybody, you might be knowing any beam which is being subjected to at any section, when the loading has been, suppose bending moment has been applied like this, means top fiber is under what, compression, and the bottom fiber is what, under tension, then we say this bending moment is positive bending moment, and this type of bending moment we are calling sagging bending moment. What we are calling? Sagging bending moment. We are calling this type of bending moment to be sagging bending moment. Whenever any part of the beam is subjected to bending moment like this, then we are calling this bending moment to be negative bending moment. We are calling this to be hogging bending moment, right? So this is a very important, because without this you cannot even start the diagram, right? You cannot start the diagram also. So this is one of the very important to note down the concept of sign conventions. Now, coming back to the example, how to draw this shear force and bending moment diagram. Very easy example we are going to start, and then we will see some of the type 1, type 2, and type 3 problems, right? Now, what are all these types of problem we will see in basically while solving the problem. You will come to know, right? Let me just consider a very famous case, a cantilever beam which is being subjected to a free end. There is a one load which are acting. Now, you try to stick with my method, which I'm telling you, which is very much suitable also, and you can draw very comfortably without having any headache, right? This is the length of the beam, let me say L. Now, before drawing the diagram, we must be able to understand the criticality of the condition. What is the criticality of the condition? We need to calculate the reaction forces. And what is the reaction force? RA W, because summation of forces in the y direction has to be 0, and summation of moment about A point has to be 0. And how to calculate the moments? Let me just take the moment to be, reaction moment to be MA, then W into L minus MA, that is equal to 0. Then what is the MA? W into L, in which direction? In these directions. Whatever the direction we have assumed, that is correct. Right? So these are the basically support reactions we have calculated, Now let's focus our attention on calculating the shear force diagram. You focus now. Very first thing I would like to tell you that shear force at point B. What you do, you just try to move, you take a section, right? For the initial few minutes, it might be struggling, but after some point of time, it will be very much clear. You know, see, I will be just considering this section just to the right of B. I'm moving like this. My movement is from where to where? My movement is from extreme right hand to extreme left hand, right? Correct. If I move from here to here, if I consider any section over here, any part of the structure beam is there? Nothing. So what is the shear force? At point B, just to the right of B. Just right of B. What is that? 0. What is the shear force at point B just to the left of B? When you consider just to the left, see, remember, whenever there is a vertical load at any point, calculate the shear force 2 times at that point, right? So just to the left of B, what is the load which are acting? Plus W or minus W according to our sign conventions. When you follow our sign conventions, what you are following, we are moving from this to this, and whenever I will find like this downward, I will be putting positive W. Getting my point? Correct. Come back to the point A. Shear force at point A, just to the right of A. Now, some of you might not be very comfortable with this method, but believe me, it will be a very, very easy method, right? Just to the right means here. Because why we are calculating 2 times once again? Because at the point A, there is a reaction force, and reaction force means vertical load, right? So whenever at any point where there is a vertical load, calculate the shear force 2 times, twice. Shear force just to the right of A. What is that value? We are moving from here to here. What you are observing? Only plus W is there. Only plus W is there. Shear force at the point A just to the left of A. Just to the left of A. Just to the left of A, my different here. Plus W already it was there. But we are able to find one load which are acting in the vertical direction, minus W. That is going to be 0. Again, some of you might be confused. So let me clear that particular A point. A point is here. When you are just taking just to the right and you are moving like this, you are only able to find only one load, that is in the what? Downward direction. And according to our sign convention, downward direction is what? Positive W. That is what we have written. Now, when you come back to the left of the point A, what you are observing, my different, not only W, plus W is also acting, then W that is downward, minus W. Why minus W? Because again, follow the sign conventions. What is the sign convention? Whenever, my different, if I move like this, from extreme right hand to the extreme left hand, and whenever I will be finding vertical load, I will be putting minus sign. Right? So plus W minus W will together will give me the value called 0. Right? Now we can draw the shear force diagram very comfortably, that something like this. There is a line, origin line, right? So when you draw my different, what you're getting, you will be getting the answer as, first of all, what is the shear force at B? Plus W here, again coming back to 0. Plus W, but again it is going to 0, right? The diagram must be closed. Then only we can say that the force has been balanced. Right? This is a positive shear force diagram. Make a note of it. Very, very important. Let's see how to calculate the bending moment. Right? Now, bending moment calculation might different. It's very easy. Bending moment calculations. What is the bending moment? When you see the diagram, our diagram is something like this. Our diagram is something like this. There is a W, and what we are having, that we are calling this to be point B, this to be point A. This is nothing but W. There is a reaction moment W into L, which is having a length of L. Now, What is the bending moment at point B? Bending moment at point B will be 0. What is the meaning of bending moment, my dear friend? The bending moment is load into distance, you know. What we are observing, my dear friend, that when you calculate the bending moment at point B, there is a W load is there, but there is no distance, you know. There is no distance. Distance has to be there, right? The distance is 0. Now, what is the bending moment at point A? The bending moment at point A, my dear friend, what you are observing, the bending moment at point A. Now, wherever there is a movement, wherever there is a movement at any point, calculate the bending moment 2 times. What you understood? Let me explain you. Bending moment at point A, when you just consider right to the A, just to the right of A. When you consider the bending moment just to the right of A, what you are getting, my different? Minus W into L. Why we are writing minus W into L? Because that will try to create a hogging bending moment like this. Perfect. And again, we are moving like this. Again, we are moving something like this. And according to our sign convention, that has to be negative. Now, what is the bending moment at point A just to the left of A? Just to the left of A. That means you have to move little bit in the leftward directions. And when you just move little bit in the leftward directions, you can see that this W into L is coming like this. Already minus W into L was being there with the help of W load. But one more movement is coming in the clockwise direction at the point A. And according to our sign conventions, it has to be plus W into L. And final bending moment has to be 0. So when you draw the bending moment diagram, what you are observing, it is nothing but something like this. This has to be a basically what? A linear line, right? And what is this particular value, my friend? The value will be minus W into L. It is 0, right? This will be your bending moment diagram. This will be your bending moment diagram. Very, very important. Please make a note of it. Let's see some of the questions that has been asked in your paper only, right? So before moving on to the questions, let's see. So this particular question, what we can see, the supported beam of the length 12 is subjected to a loading conditions like this. What you are observing, my different, you try to focus your attentions. We have to calculate the reaction force at point A, point B, point C. Let's suppose I have considered 3 point A, B, C, right? No problem. Now, I have to calculate the reaction forces also, right? Without that, we cannot draw the bending moment. That is a conclusions, we already made that conclusions. Then what is the summation of forces in the y directions? RA plus RB has to be 0. There is a known vertical force which are acting onto the beam. So RA plus RB has to be 0. And take summation of moment at any point. I'm just taking summation of moment about A point has to be 0. And then what I'm observing, RB into L is equal to M. RB, that is in the anti-clockwise direction, M is clockwise direction, that has to be what? Equally, RB equal to what? M by L. Then RA is what? Minus M by L. That means you have to reverse the assumed directions. You have to reverse the assumed directions. And what is the direction now? RA will be M by L. This will be M by L, right? So we can draw very comfortably now the bending moment. What about the bending moment at point? Let me just start from the here, right? So bending moment just to the right of C, right? Just to the right of C. Just to the right of C, and we are moving like this, nothing is there, 0. Bending moment just to the left of C, just to the left of C, what you are observing, we are moving like this, we are moving like this. At any section, when the bending moment is like this, what we have assumed? Negative bending moment, right? Minus M, no problem at all. Correct. Now, what about the bending moment at point B? Again, no need to calculate 2 times because there's no movement at the point B, no external movement. So what is the bending moment at point B, my dear friend? M minus M, right? What about the bending moment at point A, my dear friend? There will be movement because of the external movement minus M, but there is a what? Sagging moment because of the what? This RB value. So what is that particular value? Plus M by L into L. What you are getting, my dear friend? 0, right? So according to this, if you just follow, just look at the different options, what you are understanding. At the point C, we have the two bending moment. One is 0, one is minus M. It is wrong. It is showing only one bending moment. It is also wrong. Nothing 0. What we have? Only B options. One is 0 and second is what? Minus M. Here also minus M. Again getting what? 0. Perfectly B option is correct. So just with the help of very quickly, we can draw the bending moment diagram, even though without considering any section method. You might have followed any textbook, they have given section method, but those things you can avoid for a very, very simple problem, right? That can be solved within a fraction of second, right? Now, when you consider the type 2 problem, this is a type 1 problem, a very simple problem, right? Now, when you consider this type of problem, right? In this type of problem, what there's a problem in this type of category, we need to shift the loading conditions, right? In this type of problem, we have to shift the loading conditions because see, our beam is what? ABC. Our beam is not BDE. BDE is nothing but one of the extension that has been provided to this ABC support, ABC beam, right? Now, but the load is not acting on a beam. The load is acting on a BDE part. How to transfer the load from BDE to ABC member? Try understanding. This will be covered beautifully in full course. See, the load is acting B. Load is acting B. Whenever you want to transfer the load from any point to the other point, you transfer the, basically you apply just two loads, one in the upward directions, one in the downward directions, two load. What you can draw the equivalent diagram, A, B, C. This particular loads will be acting in the downward direction, this one. But what about this P and P will do? They will try to create the bending moment. In which direction, my dear friend? In this directions. So can I draw the bending moment? Yes. P into L1. That will be the equivalent figure of this particular figure that is being shown in the question, right? So what is the actual diagram? Actual diagram will be A, B, C. That means our diagram will be P, that is 100 Newton. P into L1 means what? 100 into 100. That is means what? 100 into 100 Newton mm, right? So this is nothing but, my dear friend, our type 2 problem where we are shifting the load from any member to original member, that is ABC member. And they are asking what is the maximum bending moment. So now we have to calculate the reaction support, we have to calculate the reaction support. That is there's a no doubt in that, right? So there is a RA, there is the RC, two reaction forces will be there. There is a bending moment. So RA plus RC, my dear friend, we can write 100 because summation of forces in the y direction has to be 0. Summation of forces in the y direction has to be 0, right? Now, try understanding what I'm saying to you. Summation of moment about any particular point you can take and you can just equate to 0, my dear friend. So RC into 1000, RC into 1000, and then you can write minus 100 into 500. Moment is also acting 100 into 100. That has to be equal to 0. Then what is the RC value, my dear friend? What you're going to get the RC value? 100 into 500 plus 100 into 100 divided by 1000. So you'll be getting what? RC is 60 Newton. What about RA value in that case? 40 Newton, right? You can check it out afterwards. You will be getting the 60 Newton as well as the 40 Newtons. You start calculating the bending moment at point A, 0, because there's a no value of the distance. If I move from here to here, then what about the bending moment at point B? Again, calculate 2 times. One will be left to the B, left of B. When you consider, then there is a RA, that is a 40 into what? 40 into 500. That means what? Divided by 1000. That will be getting what? Newton meter. So I'll be getting 20 Newton meter. What about the bending moment just to the right of B? Why we are calculating 2 times? Because there is an external movement, right? External movement. And how to decide the directions? It is also plus, it is also clockwise, in the sagging movement. So that will be together added. 20 plus 100 into 100 divided by thousands. You will be getting what? 30 Newton meter. What about the bending moment at point C? No need to calculate, 0. A, B, C. If you draw the bending moment diagram, what you are getting, my different? You will be getting the bending moment diagram as something like this. Two values you're gonna get 20 and 30. If you don't follow left and right method, what you will do, you will simply draw the diagram like this, and that will be wrong. And now among 20 and 30, what is the maximum bending moment at any particular point? The maximum of both the values, 30 will be correct. So this is a type 2 category problems, right? Very easy one. Left, right, we have to play, that's it, right? Now, when you consider the type 3 problems, that is nothing but internal hinge problem, right? What we are calling type 3 problem. Internal hinge problem. Internal hinge problem means, see, we have the external hinge. We are calling this to be external hinge. This particular pin support you are observing, this particular pin, this is nothing but internal hinge. Try understanding what I'm saying to you. What is the purpose? See, understanding the subject, getting the answer, qualifying the GATE examination is something else. But fundamental understanding of the subject has to be very, very important. Why we are using the internal hinge, right? Understand. There is a two beams. One is a cantilever beam. Perfect. And there's a one more beam is there, which are calling simply supported beam. Both these beams are connected. This AB and BC beams are connected together with the help of pin connections. Let me call like this. They will be added together by the pin, right? That is the purpose of the internal hinge. Internal hinge is used to connect the two different types of beams. Perfect. Now, how to calculate the bending moment at point A? So whenever there is an internal hinge, you can separate it into the two categories. You can just consider the beam as cantilever beam AB part, and internal hinge support reaction will be considered as RB like this. Second, you can make RB like this, as well as RC you can make like this, and there is a P load which are acting like this. What I have done? I have done nothing. I have just split the beam into two categories. Likewise, they have joined before. When I join together, I'll be getting this figure only, When I join together, I'll be getting this particular figure only. At the internal hinge, there should not be any forces should be visible, and that is not visible. But when I make this separate free body diagram, then only they will be making what? The forces. This internal hinge will offer some kind of reaction force in this directions that will act like a load for the for AB beam, and it will be acting like a support for BC beam. And in that case, how to calculate RB and RC? It is a simply supported beam, exactly the point load, midpoint, exactly load is there, then it will become what? P by 2, P by 2. If it is P by 2, this will also P by 2. If this is P by 2, what is the bending moment at point A? P by 2 into L. Then what's the answer? PL by 2. So many more examples are there. Many more types of categories of the problems are there. A typical problem, we will discuss. Those things we will cover in full course detail, So I hope that you particularly like this session in which we have covered the CFOs and bending moment diagrams, as well as we have seen some categories of the problem, right? Thank you all.